Alright, in this video, we're going to continue our discussion about the atoms. Here, we're going to introduce a couple of very simple but very useful concepts, which is valence electrons and also octet rule. Okay, so first of all, let's review what we did with atomic diagram. That's basically what we have learned so far about any atoms. We know there are neutrons, protons, electrons, but most importantly, we know electrons are not just random everywhere. We actually manage to put electrons onto different layers or so-called orbits, okay? And we follow the pattern that, so we can create an atomic diagram for the first 20 elements, okay? So I hope you can remember that 2882 rules. So here are a couple of examples of the atomic diagrams for sodium and chlorine. Now, because of different number of electrons, so you can imagine when you look at the atomic diagram, sodium will look like this: 2 electrons on the first layer and 8 electrons on the second layer, and there's only 1 electron on the most outer layer. Here I want to highlight this. Okay, we're looking at these orbits. Okay, these are just partially drawn circles from most inner layer, or which is the closest to the nucleus, and count and towards outside, further away from nucleus. Okay, same as with any other atoms like chlorine here. Okay, and I want to bring this up, touch on this with you briefly now, but I want you to keep in mind. Okay, when we say the orbits that's most close to the nucleus, okay, and also we're trying to differentiate the other orbits, which is a little bit bigger with the radius, which indicating a little further away from nucleus. And then you can see here the third layer is even bigger if you draw the complete circle here, okay, which is indicating the electrons located on this orbits are the furthest from the nucleus. Okay, these orbits, okay, they are indicating the geographic distribution of electrons. But more than that, they're also showing you the electrons are distributed at different energy levels. Okay, so this is the first time, but I want you to keep this term in your mind. Okay, these orbits also can be explained, interpreted in terms of energy. So the electrons located in, for example, okay, in the case of sodium, which is also true, the same concept apply to any other atoms. Okay, the electrons located on the first layer, okay, has the lowest energy. It's closer to the nucleus. So you can imagine these 8 electrons located on the second orbits, they have a higher energy than the first 2 electrons. And you can imagine the electron located on the most outer layer, okay, they have the highest energy. In this case, there's only 1 electron. Okay, so if you look at the chlorine atomic diagram, you can imagine the 7 electrons on the third layer they're not only so further away from nucleus compared to the layer 1 and the layer 2, or level 1, level 2. So from now on, probably better to say level. Okay, not only it's physically located further away from nucleus than level 1, level 2, but also these 7 electrons, they have higher energy. They are more energetic than the electrons, these 10 electrons located on the first and second levels. So here comes the first concept. Okay, valence electrons. We define the electron located on the most outer layer to be valence electrons of the atom. Okay, this is the true meaning of why do we want to know so much detailed inside information of atomic structure. We want to know how many electrons on each layer, so we can say, okay, sodium has only 1 valence electron, which is located on the third layer, and the chlorine has 7 valence electron, which is located on the third layer as well. Now, once we understand the valence electron, okay, the octet rule is very simple, which is octet stands for number 8, okay, which basically says everybody, well, not everybody has 8 valence electrons, okay, but everybody wants to have 8 valence electrons. V stands for valence electrons. So if you are naturally, like sodium has only 1 valence electron, okay, then that indicates the chemical property of sodium is to seek to be 8 valence electrons. So is chlorine. But of course, when you have one valence electron naturally like sodium, which will probably behave very differently chemically from the chlorine, which already has 7 valence electrons. For example, when you have one valence electron, you have two choices here to achieve 8 valence electron. Either plus 7, you can get 7 more, or you can simply minus 1, get rid of 1 electron. Okay, it's just like anything else in the nature. Okay, the more you have to do, the harder it's gonna be. So in the case of sodium, okay, it's always no-brainer. It's gonna try to get rid of this 1 electron. Okay, so let's take a look at what happens if sodium somehow managed to get rid of this 1 valence electron. Now it lost that only 1 electron on the third layer. Okay, now it only had 2 layers already. Okay, and this on the second layer. Now the second layer becomes the most outer layer, which has 8 valence electrons on it. Okay, so that's perfect. Okay, instead of getting 7 more, which will be way harder. Now at the same time, let's look at what's going to happen to chlorine. Okay, so in the case of chlorine, it's going to be opposite. Now it's already have 7 valence electrons, so it only needs to get 1 more. Otherwise, erase 7 electrons is going to be it's almost impossible. Okay, so getting 1 more electron seems to be very reasonable. So in the case of chlorine, instead of losing electrons, it's actually going to gain electrons. Okay, let me redraw this third layer to make it. So on the third layer now, it has, instead of 7, now you got 1 more electron, 8 electrons. Okay. Now remember that when you a neutral atom, okay, sodium, you had 11 proton, which has 11 positive charge, and 11 electron, which is 11 negative charge. So neutral overall charge is going to be 0. Okay, but now you're breaking the balance. Okay, you're not doing anything to the nucleus, so you still have 11 protons. But now you only have 2 plus 8, 10 electrons. Of course, the reason is that you lost electron. When you're losing 1 electron, when you're losing 1 negative charge, you are actually becoming positive charged. So this species right now with 10 electrons, but still has the nucleus of sodium, will be indicated by, it still belongs to sodium element, okay? But this is not neutral sodium atom anymore. Now it carries a non-zero charge with positive charge. You put the number on the right up corner, okay, indicating this is a sodium with a positive 1 charge. Okay, you have the indicated symbol. Okay, now this is not a neutral atom. It's a p species carries charge, so we call it cation. All right, so let's look over to the chlorine. Okay, the chlorine was well, it still has 17 protons in the nucleus and 17 electrons. So overall charge is 0. Now the situation is a little bit different. Okay, nothing has changed to the nucleus, neither to proton or neutron, but the number of electrons is different. Number of electrons now is, you still have 17 protons. The electron is 288. You gain 1 more electron. That makes 18 electrons. So you can do the math here. Plus positive 17 plus negative 18 gives you negative 1. So this negative 1 is because now your negative charge from electron is outnumbered by to the positive charge from nucleus by 1. So this chlorine is no longer chlorine atom. It's a chlorine negative 1 charged ion. This is called anion. Okay, so any positive charged species is called cation. Any negative charged species is called anion. They both are called cation and anion. Both are called ion. So ion means anything with non-zero charge. So you can imagine here, okay, if you happen to have lost 2 electrons, then that means you're going to be positive 2 charge. If you gain extra 2 electrons, you'll be negative 2 charge. Okay, so one of the things I want to address here is don't be confused by the symbol here. Okay, when something carries a positive charge, it means it actually lost electrons. Okay, when you are carrying negative charge, that means you gain electrons. Okay, so you can imagine when sodium and when sodium and chlorine atoms, neutral atoms, meet each other, then this is what they're gonna do. One of the sodium electron, okay, that used to be on the third layer, will be transferred from sodium to chlorine. Now, by doing this, you are making sodium perfect with 8 electrons on the outer layer, as well as chlorine with 8 electrons. So this is what we call chemical reactions. And when sodium becomes positive 1 charged, and the chlorine becomes negative 1 charged, now between the cation and anion, okay, there's natural attractive force will keep them together. Okay, so this is called, they are forming a compound. And this particular type compound formed by cation and anion, which means they're attracted to each other because of the nature of the charge, is called ionic compound. Okay, this is one kind of chemical bond. This is a, so the chemical bond between sodium cation and the chlorine anion is called ionic compound. I'm sorry, and this type of bond is called ionic bond. Okay, so the type of chemical compound is defined by the type of bond here. Okay, all right, let's take a look at another example here. Okay. Let's look at neon. Neon is number 10 elements, so that means atomic number is 10. Proton 10. Let's skip the other part though. We know electron is 10 as well. Neutron is 10 as well. Okay, or let's say now the atomic diagram from neon is going to be plus 10 neutrons and 10 electrons. 10 electrons means the first layer has 2 electrons, second layer has 8 electrons. So this is neon. Now we can see that neon naturally has 8 valence electrons. So the second layer is its most outer layer. So the keyword is most outer layer. Most outer layer or level. Okay. So in the case of neon, the most outer layer is already number 8, which is fulfilled by Octet rule naturally. So you can imagine neon is not going to form any charge with anybody. So either losing electrons or gaining electrons, it's actually too much for neon. So B itself already perfect for neon. So neon, along with other noble gases, okay, they are very, very stable, chemically stable. Chemically stable, then we say it has a very, very unique chemical property. This is what we mean by chemical properties. Okay, all right, let's take a look at another example. Okay, so does everybody has to have 8 valence electrons? Like there's a couple of exceptions. Okay, such as hydrogen. Okay, hydrogen has only 1 proton. Most of hydrogen has no neutrons and with 1 electron. Okay, now hydrogen has only 1 layer of orbits or so-called energy level. Okay, it doesn't even, the second layer is empty. Okay, nothing else. So what hydrogen tend to be like is actually, or what thing is perfect to hydrogen is actually either losing, just lose that 1 electron, which becomes H plus. And so you can see H plus representing no electron, no neutron, it's just a proton. So usually when you look at any chemistry paper or textbook, okay, electron is represented by E minus, okay, but you never see P plus or anything standing for proton, because proton is usually indicated by H plus. That's all. Okay. Now, also hydrogen would tend to get one more electron. Instead of getting 8, okay, 2 electrons on the first layer is perfect for hydrogen because the full capacity for the first layer is 2 electrons, it's not 8. So by getting one more electron, okay, from 1 electron, getting one more becoming 2 electron will give hydrogen negative charge. So hydrogen is one of the exception of octet rule. It does not require 8 valence electrons. So you only want to fulfill the first layer completely by getting one more electron or losing that electron you only had, become a new proton. Okay, so these are, so you can say hydrogen has a very unique chemical property by either being able to get in positive charge or negative 1 charge. Okay. By looking at by looking at the periodic table, okay, you can try to practice first 20 elements, how to draw the atomic diagram, and so you can try to predict how many valence electrons they have, and then compared to number 8, what do you think they're gonna do? Okay, so we're gonna continue this discussion in the next video.